Welcome to Mr. Tompkins Ed Tech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers simultaneous equations. I've taken related questions from my past paper walkthroughs and given them to you here back to back. This series is intended for the last few weeks of your revision, and my advice is to go through all the practice papers and past papers before you look at these, or the compilation videos will be the mathematical equivalent of endgame spoilers for you. Having already worked through all the practice papers, these compilation videos will give you a deep dive on topics you are still finding challenging, give you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. Question 10 has a fairly straightforward pair of simultaneous linear equations. I'm going to be using the elimination method to solve this. Let's label that one equation 1 and equation 2. So to eliminate x, I'm going to take equation 1 and I'm going to subtract 2 lots of equation 2. So let's just write equation 1 out again. 2x plus 3y is equal to 15.5, and then we're going to write equation 2 underneath, but we're going to double everything up. So we're going to get 2x plus 2y equals 12. Okay, now we can simply subtract one equation from the other. 2x take away 2x is there's nothing. That's what we've done. We've managed to eliminate x. 3y take away 2y leaves us y, and 15.5 take away 12 leaves us 3.5. Okay, so we found y. Now we need to find x. To do that, we just need to substitute that back into one of our original equations. So substitute y equals 3.5 into, which one looks easier? I think I'm going to substitute into equation 2. So x is what we want to find, plus y, which is 3.5, is equal to 6. So rearranging that, I'm going to get x equals 6 minus 3.5, which is going to give me 2.5, my answer for x. Okay, now I am done, but it's always a good idea to check. So checking both of our answers by substituting into the other equation that we didn't use to find x. Just quickly, so 2 lots of, so this is a check, isn't it? Check. 2 lots of x, 2 lots of 2.5 plus 3 lots of y, 3 lots of 3.5. Is that equal to 15.5? Okay, so 2 lots of 2.5 is 5, 3 lots of 3.5 is 10.5, and together, yes, they do make 15.5. So I'm quite happy that my answer is correct. Okay, so now I'm satisfied. I'm just going to write those two values in here. So x is 2.5 and y is 3.5. Question 10. At a concert, 3 adults and 4 children's tickets cost £23, and 1 adult and 5 children's tickets cost £15. Work out the cost of an adult ticket and the cost of a child ticket. Okay, when you've done as many past papers as I have, you'll see immediately that that is actually a simultaneous equation. So we'll let the cost of the adult ticket be x and the cost of the child ticket be y. So we can rewrite those two statements as 3x, 3 adult tickets, plus 4y, 4 child tickets is 23. And the second statement says x plus 5y equals 15. Right, so we need to eliminate either x or y. I think the easiest way would be to take this second equation and multiply it by 3 and then subtract. So let's just take 3x plus 4y equals 23 and then multiply the second one up by a factor of 3. 3x plus 15y is equal to 3 lots of 15 is 45. Okay, I'm going to subtract, but I'm going to subtract uphill kind of. I'm going to subtract the top equation from the one underneath it so I can keep my y's positive. So 15y subtract 4y is 11y. Obviously they cancel. And 45 subtract 23 is, handy, 22. Meaning y is equal to 2. Now I found y, I just need to sub it back into one of my original equations. So substitute y equals 2 into equation 2. That looks like the simpler one of the two. So x plus 5 lots of 2 is equal to 15. So x is going to be equal to 5. So the adult ticket was the X value, they're a £5, and the child's ticket is £2. Always a good idea to check these. So quick check. We used equation 2 for working out x, so let's check in the other one, equation 1. So 3 lots of 5 plus 4 lots of 2. Is that equal to 23? Well, 3 5s are 15 and 4 2s are 8. And 15 plus 8 is 23. So yeah, it does work. Okay, now a little check like that only takes a minute or two. And then you can, but the plus side is you'll leave the exam knowing that you've got those 4 marks in the bag. Question 12. I am thinking of two numbers. If I multiply the first number by 4 and add the second number, the answer is 32. If I multiply the first number by 2 and add the second number, the answer is 23. Work out the two numbers. Now this is just a pair of simultaneous equations given as a written question rather than as their equations, but we can quickly just write down what the equations are. So if I multiply, let's say that my two numbers are x and y, then if I multiply the first number by 4, I've got 4x, and if I add on the second number, I'm going to be adding y, and I get the answer, which is 32. And then if I multiply the first number by 2, which is 2x, and add the second number, y, I get the answer 23. Okay, so we've just got a pair of simultaneous equations. I'm going to call that one equation 1, that one equation 2. So you'll notice that these are the same. It should be very easy to solve this by elimination. So let's subtract one from the other. So equation 1 subtract equation 2. What does that give me? So 4x take away 2x is 2x. Y take away y is nothing. And 32 take away 23 is 9. So I've got 2x is 9. So x must be 4.5. Okay, so I've got what x is. Now I need to work out what y is. So I just need to substitute x equals 4.5 into one of our equations. Equation 2 looks more looks simplest, so let's sub into that one. So 2 lots of 4.5 plus y is 23. So 2 4.5s is 9. 9 plus y is 23, making y equal to 23. Subtract 9, which is 14. Now, it's always a good idea to check these. So before I move on, I'm just going to check. And I can do that by subbing both numbers into one of the equations, usually the one I haven't used yet. So I used equation 2 to work out what y is. So let's sub x and y into equation 1 and check it there. Okay, so 4x plus y is 32. So if x is 4.5, I'm going to have 4 lots of 4.5 plus y, which is 14. Now, is that equal to 32? Well, lots of 4.5 is 18. 18 plus 14. Is that 32? Yes, it is. So I've quickly checked it and I'm pretty convinced I've got the right answers. So x is 4.5 and y is 14. Question 13. Here is a formula. Question 12. Solve the simultaneous equations 3x plus 2y is equal to 10 and 3x minus y is equal to 13. Now you notice that these two values of x, the coefficients, are the same. So this question lends itself very well to solving by elimination. So let's call this one equation 1 and this one equation 2. Then equation 1 subtract 2. So taking the second equation away from the first, so 3x take away 3x, they're going to cancel each other out, aren't they? Just take care when you're subtracting negative signs here. So 2y take away negative y is 3y, and 10 take away 13 is minus 3. So that's going to give me y is equal to minus 1. Okay, so now substituting back into one of our equations. Substitute y equals minus 1 back into, should we pick equation 1? So then I've got 3x plus 2 lots of minus 1 is equal to 10. 2 minus 1 is negative 2. Taking that to the other side. So taking that over there, I'm going to get 3x equals 12, give me x is equal to 4. So that would tell me that x is 4, y is minus 1. Always a good idea to check these just by subbing both values into the second equation, the other equation we didn't use. So 3x minus y equals 13. So 3 lots of 4 minus negative 1. Is that equal to 13? 12 subtract negative 1, 12 plus 1 is 13. So yes, it does work. Always a good idea to do checks in the exam. You'd better to find out in the test that you're wrong rather than when your results come back. Question 10. Solve the simultaneous equations 2x plus y is equal to 18 and x minus y is equal to 6. Now you should have a few methods up your sleeve for solving simultaneous equations, either by elimination or substitution or graphically. Here, this particular pair of equations lends themselves really well to elimination. You can see I've got a plus y and a minus y, so I can eliminate y very easily by adding these two equations together. So what is 2x plus x? It's 3x. What is y plus negative y? They're going to cancel each other out. And what is 18 plus 6? It's 24. So I've got 3x is equal to 24. That means that x must be equal to 24 divided by 3, which is 8. X is 8. Okay, so then I can just substitute that back into one of my original equations. Let's take the first one. So 2 lots of 8 plus y is equal to 18. So 16 plus y is 18. That gives me y is equal to 2. Then doesn't 18 take away 6? So my two answers then are x is 8 and y is 2. Now it's always worth just double checking these. We used the first equation, 2x plus y is equal to 18, for our working out of y. So let's just double check both solutions in the second equation. So check. I've got x minus y equals 6. So if x is equal to 8 and y is equal to 2, does that equal 6? Yes, it does. So that's just a quick check that you should do in the exam to make sure that you've got the right answer. Question 20. A linear sequence starts a plus 2b, and then a plus 6b, then a plus 10b, and so on. The second term has value 8, the fifth term has value 44, work out the values of A and B. So it's kind of an interesting question. So it's chucking in simultaneous equations in with sequences and a little bit of algebra. It's lovely. Okay, so you can see from one term to the next, what is the term-to-term rule? I've got A plus 2B, and now I've got A plus 6B, which is 4B more. So I'm adding 4B each time, and again, there we can see I've gone up by another 4B. So my next two terms then are going to be A plus 14B and A plus 18B. Now I'm told in the question that the second term has value 8, so this one was worth 8, and the fifth term has value 44, so this term here is equal to 44. So what I've got then is a pair of simultaneous linear equations in A and B. So this term here, look, gives me that A plus 6B is equal to 8, and this one here gives me A plus 18B is equal to 44. Okay, so that's equation 1, equation 2. Now we're going to subtract one from the other, aren't we? I'm just going to subtract uphill. So equation 2 subtract equation 1. So A subtract A, they cancel each other out. 18B subtract 6B, that's giving me 12B. And 44 subtract 8, that is equal to 36. Okay, so I've got 12B is equal to 36, dividing both sides by 12, or cross multiplying 12, whichever way around you do it, gives me B is equal to 3. Okay, now I've got B. I can work out A, can't I? So let's sub that back in. So then substitute B is equal to 3 into, could be either one. I'm going to go for the simple one. I'm going to go for equation 1. So substitute B is equal to 3 back into equation 1. That tells me that A plus 6 lots of 3 is equal to 8. Well, that is A plus 6 3s are 18. A plus 18 is 8. Change sides, or subtract 18 from both sides, whichever way you want to think about it. A is going to be 8 subtract 18, which is negative 10, isn't it? Okay, always good to check. You've got another equation that you can check with. So I've got, in the second equation, I've got A plus 18B. A plus 18B is 44. Is that true if I sub in my two values that I found? So if I sub in minus 10 for A and 18 lots of 3, is that equal to 44? 18 threes, 18... well, 3 20s is 60, so 3 18s is 54. Take away 10 is 44. Yeah, that is true. So it works. So it's always good to check in the exam if you can. Much better to check it here and make correct any mistakes then after you've finished, because you can't then. So A is minus 10 and B is 3. Job done. In question 28, I have a pair of simultaneous equations that I need to solve. Now note that I have got a x squared term in here, so it's not a case of just trying to find the same coefficients and subtracting to eliminate one of x or y. It's not going to work. What I'm going to have to do instead is substitute one equation into the other. So I'm going to take equation 1, let's call that one equation 1, and equation 2. Let's take equation 1 and rearrange. So rearranging equation 1. So 5x minus y is 5, so making y the subject. Y then is going to be 5x minus 5. And substitute into equation 2. So where we see y, we're now going to write 5x minus 5 instead. So equation 2 says 2 lots of y, 2 lots of 5x minus 5. minus x squared is equal to 11. Okay, just multiplying out those brackets. 2 lots of 5x is 10x. 2 lots of minus 5 is minus 10. Gives me that. Now I'm going to collect everything on the right side, so my x squared term becomes positive. It's going to move that over to the other side, and that. They're all going to go over to the other side. So leaving me 0 on this side. So I'm going to get my 11 from before, plus my x squared, plus my 10, minus my 10x. Okay, just tidying that up. So I'm going to get x squared minus 10x, and 11 plus 10 is 21, plus 21 is equal to 0. Okay, so I've got a quadratic in x. Now in order to solve this, I'm going to need to try and factorize that. So can I break it into 2 brackets? Well, if I can, it's going to have an x here and an x here. Let's have a look at the 21. Factor pairs of 21. I've only got 1 and 21, or 3 and 7 that I can try. So which pair of those makes 10? It's going to be the 3 and 7, isn't it? So it's going to be x minus 3, x minus 7. That's going to deliver me the plus 21 at the end and the minus 10 in the middle. So x equals 3, x equals 7 is the solution for x. Now don't forget we had some y's to find as well. So we're going to have to substitute those back in. Substitute into our rearranged equation 1 gives us y equals 5 lots of 3 minus 5. 5 lots of 3 is 15, take away 5 is 10, or y equals 5 lots of 7, take away 5. 5 7s are 35, take away 5 is 30. Question 20. A knife is twice the cost of a spoon, and 8 spoons and 12 knives cost £46 and 8 pence. Work out the cost of one knife. So actually here we got a pair of simultaneous equations. Let the cost of the knife be k and the cost of the spoon be s. Then this first sentence here gives me an equation for k and s. It says the knife is twice the cost of the spoon. So k equals 2s. So that's our first equation. Our second line, 8 spoons and 12 knives cost £46 and 8 pence. So 8s plus 12k equals £46 and 8 pence. That's my equation 2. So if I substitute equation 1 into equation 2, so substitute 1 into 2, so I'm going to replace my k's with 2 s's. So I'm going to replace my k with 2s. So 8s plus 12 lots of 2s equals £46 and 8 pence. So how many s's is that altogether? Removing the brackets gives me 24s plus 8s is 32s. So 32s equals £46 8. So 46.08 divided by 32 tells me that spoons must be £1.44. And then if spoons are £1.44, then k is going to be 2 lots of that, then, isn't it? So that makes knives £2.88. So £2.88 is my final solution. Question 13. We're given that the ratio of x to y is 7 to 4 and that x plus y is at 88, and we need to work out the value of x minus y. Okay. So now this is well, if I rewrite this, x to y the ratio of x to y is 7 to 4. If I write that as an equation, I can say that y then is equal to, well, take x, I can get y if I divide it by 7 and times it by 4. So 4/7 of x, y is 4/7 of x. Now you've got two different methods for solving simultaneous equations, either by elimination or by substitution. This one lends itself more to solving by substitution, so that's the method that I'm going to pick. So I'm going to call this one here equation 1 and this one equation 2. And I am going to substitute. Oops, no, I'm not going to write in that weird pen. I'm going to substitute equation 1 into equation 2. So that gives me x plus y. Now I know from the other equation that y is equal to 4 lots of x over 7. So x plus 4 lots of x over 7 is equal to 88. Okay, so how many x's have I got? If I've got x plus 4/7 of x, x is 7/7 of x. So 7/7 of x plus 4/7 of x is 11/7 of x. So 11x over 7 is equal to 88. So dividing through by 11 and timesing through by 7 should give me x. So then x is equal to 88 divided by 11 is 8 and times by 7 is 56. So x is 56. Okay, so I know that x is 56 and I know that x plus y is 88. So y must be equal to 88 take away 56, which is 32. Question 26. A curve has equation y equals 4x squared plus 5x plus 3. A line has equation y is equal to x plus 2. Show that the curve and the line have exactly one point of intersection. Do not use a graphical method. Okay. Well, I am going to quickly use a graphical method just to illustrate the point. If you've got, well, the first one is clearly a quadratic curve, isn't it? So it's like a parabola. And the second graph is an equation of a straight line. So either your equation of your straight line is going to kind of skewer your parabola in two places, in which case you will have two solutions, 2 points of intersection, or your parabola and your line are just going to touch like that, in which case you have 1 point of intersection, or your parabola and your line totally miss each other like that, in which case there are no solutions. So we are assuming then, or wanting to show that it's this scenario there, that there's just one solution. But we're not allowed to do it graphically. We're going to have to do it algebraically. Okay, so we want to basically solve these simultaneously, which is very easy to do because this is in terms of y and this is in terms of y, so we can just substitute one inside the other. So this is equation 1, this is equation 2, and we're going to substitute equation 2 into equation 1. So we're going to start with equation 1, 4x squared plus 5x plus 3, and we're going to sub in for y is equal to x plus 2. So we're just going to connect them where the y's are. Okay, so 4x squared plus 5x plus 3 is equal to x plus 2. Okay, taking x away from both sides. So if I subtract x from here and subtract x from here, I'm going to get 4x squared plus 4x plus 3 is equal to 2, but I'm also going to subtract 2 from both sides. Okay, and that's going to leave me with 4x squared plus 4x plus 1 is equal to 0. Okay, collecting everything on one side, that is. So I've got 4x squared plus 4x plus 1 is equal to 0. I want to now factorize it if possible. So I've got a 4x at the beginning, a 4x squared at the beginning, and I've got a 1 at the end. Okay, so that must be a 1 and a 1, because I can only multiply 1 with 1 to get 1. Now, I could have 4x and x in here, or I might have 2x and 2x. 2x times 2x is also 4x squared. I'm suspecting it's this one because I'm expecting there to be a repeated root. If I got 2x times 1, that gives me 2x, and 1 times 2x is going to give me 4x, so that is actually the solution, isn't it? It's 2x plus 1, 2x plus 1. In other words, you've got 2x plus 1 all squared is equal to 0. So when is 2x plus 1 equal to 0? It's equal to 0 when x equals minus a half. So we've got a repeated root here with one solution. X equals minus a half. So therefore, one solution only. Oops, can't spell only. Only x equals minus a half. Job done. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.